Hello everybody. Today's lesson is over factoring polynomials in which the coefficient before the x squared does not equal 1. So in the last section we learned how to factor polynomials when the number in front of the x squared was 1. Okay, but now all of our problems are not going to be 1, which means we just have a little bit more to look at. So as you notice here from the example that's on the screen, if I multiply 3x times 2x, that gives me my 6x squared. When I multiply my 2 times the 5, that's 10. But notice now that, that 10 plus 6 is not this 16. That is because we have now this coefficient in front of this 6. So we have a little bit more to work with. So let's look at this example right here. As we're going to follow the exact same steps that we did in the last lesson, which is making the t and the x. So remember, to get the top of the x, we take the very first coefficient, which is 6, and the last constant, and we multiply those together to get the top number in our x. So 6 times 3 is going to give me 18. The bottom number in your x is still going to be that middle number right there, 11. I'm still going to come up with two numbers that multiply to give me 18, that add to give me 11. That is going to be 9 and 2. Now I'm going to take my 6x, my first coefficient with the variable, and put that at the top of my t, 6x and 6x. Underneath that, I'm going to put the 9 and the 2. We should be very used to it up to now. Now this is the point that's a little bit different. Now I need to, remember we're thinking of these things here sort of as fractions, even though they're not fractions, but as if it was a fraction, I need to simplify that. How can I simplify 6 over 9? Well, 3 goes into each of those, so I'm going to simplify that and make this a 2x and make my 9 a 3. All I did was basically factor out a 3 from each one of those. Now, the 6x and the 2, when I look at this right here, I see I can factor out a 2. So 6x divided by 2 gives me 3x, and 2 divided by 2 is 1. Now, I have the simplified answers that are going to make my two binomials. So my first binomial is going to be 2x plus 3, and my second binomial is 3x plus 1. So that is the only additional step that is needed in these problems when the coefficient is not 1. We're just going to have to worry about simplifying our answer a little bit, whereas we didn't used to have to do that. As always, we can check this answer by multiplying 2x plus 3 times 3x plus 1 and making sure that we end up with what we started with, the problem. Okay, let's try another one. I'm going to make my t and my x. In the x, I'm going to have 5 times negative 3, negative 15. The bottom is going to be my 2, the middle term. What multiplies to give me negative 15 that adds to give me 2? That's going to be 5 and negative 3. Okay, so now when I'm making my t here, I'm going to put the 5k at the top, 5k, 5k, and then I'm going to put this 5 and negative 3 underneath, and I'm going to simplify wherever I can. So when I look at 5k and 5, I'm going to simplify that to being 1k and 1. 5k and negative 3 cannot simplify that any, so it stays as is. Now I take what I'm left with and put these into my two binomials. 1k plus 1 times 5k minus 3. Remember, you don't have to put this 1 right here, so if you want to just write it as k plus 1 and then 5k minus 3, that is just great as well. Also remember, this is the exact same answer as 5k minus 3 written first, and then the k plus 1 written next. Doesn't matter the order in which we multiply two things. Okay, let's look at our next example. Here, we have the area of a rectangle. I'm given the area, and I want to find an expression for the length and the width. Well, I know that a length times a width equals an area. So this is simple. If I can just factor this out, I'm going to be left with two binomials. I think one binomial would represent the length, and the other would represent the width. So let's just factor this. In my x, I'm going to have 5 times negative 4, negative 20 on the top, negative 8 in the bottom. I know that that's going to give me a negative 10 and 2. Then when I come over here to my x, or my t, I'm sorry, I have 5x and 5x, negative 10 and 2. When I simplify that, that simplifies to 1x and negative 2. I'm going to take a 5 out of each one. My second binomial, 5x and 2, no way to simplify that, so I just leave it as it is. Then I take my two binomials, x minus 2 and 5x plus 2. Now, we don't know which one is the length and which one is the width here because they didn't give us that sort of information, but I know that one of them is the length and then the other is the width. So that's what we know from that problem because they multiply together to give us the area. Last one, guys. Negative 4x squared plus 4x plus 3. Notice in this problem how I'm beginning with a negative. None of our other examples have done that. Okay, this is something that when this happens, we want to do something specific. We want to factor out the negative. I don't want my first term to start with a negative. So before I get going, I'm going to factor out a negative 1 from each of my terms in this trinomial. If I factor out a negative 1, I think negative 1 times what gives me 4x squared? Well, that would be a positive 4x squared. That is the goal right there, is to get inside my parentheses here a new trinomial in which my leading coefficient is a positive number. So I get 4x squared, and then this would give me minus 4x and minus 3. Okay, so all I did, guys, was factor out this negative right here. If I multiply it back in, I get exactly the problem that I started with. So I did not change the value of the problem at all. It just looks different. Now I'm going to just worry about factoring this inside trinomial right here. I'm ignoring the negative 1 for the time being. So when I make my x, I'm going to have negative 12 up top, negative 4 on the bottom. When I think of that, I see that it's going to be negative 6 and 2. When I make my t, I have 4x, 4x, negative 6 and 2. And when I come down here, I'm going to get 2x minus 3 and 2x and a 1. Now, when I write out, this part's important, when I write out my binomials, 2x minus 3 and 2x plus 1, I am not finished. Because if I were to multiply those two binomials together, I'm going to get a positive 4x squared minus 4x minus 3, which is what I got right there. So my answer is not complete without putting the negative 1 that we factored out of the polynomial to start with back in our answer. So your answer is going to look like what's inside the the blue rectangle right there. The negative 1 just hangs out at the very front, and then our two binomials are written after that. This is going to help us, guys, whenever we get to solving quadratics, when we really start getting an actual answer for x. That's why we're factoring out the negative 1. Doesn't make a whole lot of sense right now, but when we start solving problems and putting applications in this, it will make a lot more sense. That's it, guys. See ya.